The bright source near the bottom of this image, Sagittarius A, pronounced Sagittarius A star, is thought to be the location of the supermassive black hole at the center of our home, the Milky Way. See the filament appearing to point toward it. The filament might be caused by high-speed particles kicked away from the black hole, or it might be something even stranger. Image via NSFVLAUCLAM. Morris al. CFA. One of the most mysterious and interesting known locations in our neighborhood of space is the center of our home, the Milky Way. It's thought to contain a supermassive black hole, with a mass of some 4 million suns. Astronomers call this region and its possible black hole Sagittarius A, aka SGRA, pronounced Sagittarius A star. In 2016, Fahad Yousefzada of Northwestern University reported his discovery of an unusual filament in this region. The filament is about 2.3 light-years long and appears to curve around the site of the black hole. Now, another team of astronomers has employed a new technique to obtain a high-quality image of the curved filament. These astronomers said their new image supports the idea that the filament is pointing toward the black hole. The new image has led to some fascinating speculations as to the nature of this mystery filament. A paper describing the new image, and astronomers' ideas based upon it, was published in the December 1, 2017 issue of the peer-reviewed astrophysical journal Letters. Mark Morris of the University of California, Los Angeles, led the imaging study. He said in a December 20, 2017 statement from the Harvard-Smithsonian Center for Astrophysics CFA, with our improved image, we can now follow this filament much closer to the central black hole, and it is now close enough to indicate to us that it must originate there. However, we still have more work to do to find out what the true nature of this filament is. Artist's concept of Milky Way, showing the locations of the central, supermassive black hole in our solar system. The entire is about 100,000 light-years across. Our Sun lies about 26,000 light-years from the center. Image via Zemescience. Researchers have considered 3 possible explanations for the filament. The first is that it is caused by high-speed particles kicked away from the supermassive black hole. A spinning black hole coupled with gas spiraling inwards can produce a rotating, vertical tower of magnetic field that approaches or even threads the event horizon, the point of no return for infalling matter. Within this tower, particles would be sped up and produce radio emission as they spiral around magnetic field lines and away from the black hole. The second, more fantastic, possibility is that the filament is a cosmic string, theoretical, as yet undetected objects that are long, extremely thin objects that carry mass and electric currents. Previously, theorists had predicted that cosmic strings, if they exist, would migrate to the centers of galaxies. If the string moves close enough to the central black hole, it might be captured once a portion of the string crosses the event horizon. The final option is that the position and the direction of the filament aligning with the black hole are merely coincidental superpositions, and there is no real association between the two. This would imply it is like dozens of other known filaments found farther away from the center of the. However, such a coincidence is quite unlikely to happen by chance. Each of the scenarios being investigated would provide intriguing insight if proven true. The scientist's statement continued. For example, if the filament is caused by particles being ejected by SGRA, this would reveal important information about the magnetic field in this special environment, showing that it is smooth and orderly rather than chaotic. The second option, the cosmic string, would provide the first evidence for a highly speculative idea with profound implications for understanding gravity, space-time and the universe itself. Evidence for the idea that particles are being magnetically kicked away from the black hole would come from observing that particles further away from SGRA are less energetic than those close in. A test for the cosmic string idea will capitalize on the prediction by theorists that the string should move at a high fraction of the speed of light. Follow-up observations with the VLA should be able to detect the corresponding shift in position of the filament. Even if the filament is not physically tied to SGRA, the bend in the shape of this filament is still unusual. The bend coincides with, and could be caused by, a shock wave, akin to a sonic boom, where the blast wave from an exploded star is colliding with the powerful winds blowing away from massive stars surrounding the central black hole. Co-author Milagos, from the National Radio Astronomy Observatory in Socorro, New Mexico, said, "We will keep hunting until we have a solid explanation for this object. And we are aiming to next produce even better, more revealing images." An annotated image of the great cosmic filament at the center of our Milky Way. This radio image is from the NSF's Carl G. Jansky Very Large Array image via NSF-VLAUCLAM. Morris al. CFA. Bottom line, astronomers have obtained a new image of the 2.3 light-year-long filament that curves around Sagittarius A, the region of our thought to contain a supermassive black hole. Source: a non-thermal radio filament connected to the galactic black hole. Via CFA.